Before we look at how computers could be used to solve problems, let's first study how we usually solve real-life problems. Here is the problem-solving process that we usually follow in solving a problem, not restricted only to the use of computer. The first step is to define and analyze the problem that you are trying to solve so that you can get a good understanding of the problem. In this step, basically, you are trying to come up with a problem specification. This is especially important when one is solving problems using a computer. The computer cannot read your mind. You have to give computers precise instructions on the steps to follow. So this step is very important because you have to give yourself a good understanding of the problem before you can tell the computer what you want it to do. After you have a problem specification, the next step is to develop a solution. In many problems, there could be multiple solutions, so you want to develop a solution that best fits your current situation or constraints. For example, if you want to solve the problem of getting to one place to another, the constraints could be that you have to get there by a certain time and within a certain budget. After you have decided on a solution, you will need to design the implementation details, including a step-by-step implementation of the solution. After you finish implementing the solution, you have to perform some testing and evaluation to make sure that the implementation is actually solving the right problem. This is very important because your solution may not be able to handle all problem cases. This is often an iterative process. You may have to revise the solution or to improve it in order to satisfy all the constraints and conditions. Last but not least, you should document your solution so that if you or other people want to revisit the problem at a later time, you will still be able to understand the solution easily. The documentation would also help to maintain the solution in case if it needs to be revised or updated for possible future changes. To use the example that we have just discussed about finding a way to travel from Hong Kong to London, assume that you are a travel agent. The problem definition could be something like to find the best way to travel from HKUST in Hong Kong to London in UK for your clients. In analyzing the problem, you may have to find out from your clients what he or she means by the best way. Whether it's the shortest distance, the fastest time, or the cheapest cost. A preliminary design could start by considering all possible routes and modes of transportation, perhaps by using Google Maps or other travel services websites such as Kayak, TripAdvisor, or Priceline. To refine the solution, one would have to evaluate different routes and modes of transportation, and then select the route that best meets your goal, for example, the shortest route or the cheapest cost. Once you have decided on a solution, the testing part could be difficult for this particular problem without actually making the trip, unless your boss is kind enough to let you try out the trip. If not, then you may want to evaluate the solution by checking the online track record of certain flights to make sure that there is enough time for making the flight connections if needed, or to ask someone with prior experience in making similar trips. You would then need to document your solution by providing simple to follow instructions to your clients so that he or she would not miss a flight connection or would have enough local currency for making the public transportation. After your clients completed the trip, you may want to collect feedbacks from him or her so that you can keep a record on whether the experience was positive or to revise the solution if your clients was not happy with the experience. These are the equivalent steps when one tries to program a computer as a problem-solving process. In defining a problem for a computer, we have to come up with very precise problem specifications. One common approach is to come up with a specification for the initial state or input specification and final state or output specification for the problem. This is helpful because the way a user interacts with a computer is often through input or output devices. You would then have to find out what additional information is needed in solving the problem. Using the previous problem as an example, you may have to find out what time you have to arrive at the destination and how much money you are willing to spend. When we develop solutions for real-life problems, we often write down the steps in certain language, such as English or Chinese. When solving problems using a computer, you also want to list out the steps in a language that is easily understood by all those who are involved in solving the problem. This is especially important if you are working as a team. Such sequence of steps is often called an algorithm. In general, an algorithm is a sequence of precise steps in English or other human language for carrying out certain functions. Very often, the algorithm would have to be developed at different levels of details through an iterative process. This approach is often called stepwise refinement. The above are the preparatory steps before we could actually implement a solution or start coding a program. One may think that implementing a program is the most difficult step, but it's often the case that if you have done a good job in the preparatory process, the coding step will be straightforward, and the translation from a very well-designed algorithm would be the easiest part among all these steps. So when you are solving a complex problem, you are advised to resist the temptation to start coding before you have a thorough understanding of the solution to a problem. Another decision that one would have to make in the implementation process is to determine what programming language to use and what representation to use for different aspects of the problem. After finished coding a program, it would have to be compiled to compute executable code and test the program using different scenarios to check if it works correctly under different conditions. If an error occurs, or if the program is not working as intended, one would have to track down the mistakes. This step is often called the debugging step. For historical reason, the term debugging is used because the first known computer bug was found in 1947 when a moth, a kind of bug, was trapped in a relay of a computer. The bug was taped on the logbook of Grace Hopper, a computer pioneer, and what you see here is now kept in the Smithsonian Museum. For complex problems, it is important to test the program under different scenarios. A program that works for one case doesn't mean that it will work for all cases. It is helpful to come up with a test plan to cover a common set of test cases that one would expect the computer to encounter. The test could lead to two common types of error, namely syntax error or semantic error as discussed earlier. It is important to document and maintain the program, especially for programs that are expected to last for a long time and to be reused, revised, and modified by others.